In this video, we're going to have a serious talk about colour, how we understand and interpret colour, and work our way around the chaos and confusion that exists around the world of colour. And we're going to also look at why most of what we think we know about colour is probably wrong. And in this video, there are 7 things that we're going to look at in relation to the major problems around colour. Now, in the world of black and white photography, things were a lot simpler. We just had to deal with tonal values. But once we introduce colour, we start to introduce a whole range of problems. And the first problem we have is that colour does not exist. And when we say that, we mean that as far as we're able to understand, what we see of the world around us and the colours that we understand exist purely within our mind. In a book by a professor from Pittsburgh University, he said, of all the properties that objects appear to have, colour hovers uneasily between the subjective world of sensation and the objective world of fact. And that means that what we think we understand of the world of colour might purely just exist within our brains. And that's a pretty sobering thought. But let's have a little look further. What is colour anyway? When we think about colour, colour comes from light and from the visible part of the electromagnetic spectrum that our eyes are sensitive to. And we've broken that visible part of the spectrum down into the colours that we know. So when we look at a part of the natural world, like these coloured flowers, when we see something purple, it's because the plants absorb all other colours and reflect the colours that make up purple. That's all very well, but what about our fellow creatures? How do dogs see the world, for instance? We know that dogs have limited colour vision, but what do they see? Well, it turns out that dogs have limited vision in the red, yellow, green part of the spectrum and see the world much differently from we do. When we look at these beautiful flowers and admire the colours, a dog would look at that and see much less interesting colour, much more subdued and much less interesting. And so the rest of the world that the dog sees would look something more like the image on the left rather than the image on the right. But what about birds? Birds are renowned for having incredible vision. How do birds see the world? Well, it turns out that birds can see far into the ultraviolet end of the spectrum. They can see the red colours that we see, but they also see far beyond that. So when we see a dark coloured bird, another bird might see something much more colourful. And what about the insect world? Flowers are designed to attract bees, not humans, and so how flowers appear to bees is quite different from how we see them. Bees also see far into the ultraviolet part of the spectrum, and so when we see a yellow flower, a bee might see something quite different. And so in summary, colour is an illusion, exists in our brains. Problem number 2. Everyone sees colours differently. We see how animals see the world differently, but between different people, some people have less sensitivity to other colours, so that when we see a test colour chart, some people can't see the numbers. And so when we translate that to the real world, when we see a bright, colourful image of part of the world with our normal colour vision, people with, say, reduced red sensitivity will see it something like this, with much less vibrancy. And let's say, for instance, people with reduced blue and green colour vision would see it something like that. So everybody sees the world completely differently. Which brings us to problem number 3. What we see largely depends on what we expect to see. Our brains are really good at interpreting lighting and fooling ourselves into thinking what we're seeing is accurate. When we see a white sheet of paper under normal lighting, we know it's white. But if we see that same sheet of paper under different lighting, our brains still interpret that as white. And so when we see a darkened room, we remember that there are colours there, but we can't really see the colours under poor lighting. Our brain puts back the colours that we don't see. So what we expect to see is different from what we actually see. Which now moves us on to problem number 4. The human eye is a very poor instrument. Now, some religious fundamentalists believe that the eye is evidence of intelligent design, but that's not the case. The eye only makes sense if we interpret it as being evolving from a very simple structure into what we have today. I mean, why would you put a blind spot right in the central part of our vision? And we know we only have limited colour cones in the centre of our visual cortex, and the side parts of our vision are very poor at reproducing colour and vision. So when we look at a scene in the real world, our brains fool us into thinking that we see everything sharply focused. But our eye actually only has a small part of sharp focus and colour, and as our eye wanders through a scene, we pick up those different parts in clear focus, and then our brain puts that all together and fools us into thinking that what we're seeing is all purely, sharply and well defined, and that's not the case. Which brings us now to problem number 5. We think what we see is real, but our perception is easily fooled. Take this example of a checkerboard with a shadow running across it. We think the two squares A and B are the lighter and the darker squares, but if we remove the context, in other words mask everything out except the two squares, we see that they're exactly the same tone, yet our brains are telling us they're different. Or take this example of the cube. We have a bright orange square in the middle of the front face and a much darker one on the top, and yet same thing again. Take away the context and we see those two colours are exactly the same. This is because our brains are fooling us because of the context and the lighting around these colours. And this makes a difference when we look at things like a mount or a mat board around our image. A light mat board gives a totally different impression from a dark mat board. Colours appear brighter or darker depending on the colour of the surround. And the same with another image. A dark mat board versus a light mat board makes a big difference because our perception is being fooled by the surrounding colours. Which brings us to problem number 6. We see things that aren't there. Our brains are programmed to recognise faces wherever we look. Take this rock pattern. We think we see a face there, but there is no face. It's just a pattern in a rock. Or if we look at this forest scene in Tasmania, by simply changing the hue of part of the image, all of a sudden our brains tell us that there's a creature there emerging from the undergrowth, but it's not really there. Or this rock wall in Greenland. If we change the hue slightly, all of a sudden we see a troll pushing its way out from between the rocks, but it's not really there. Our brains make these things up based on assuming that there are faces there. Which brings us to our final problem. We see in 3 dimensions. We have 2 eyes, and given we have a lot of problems with interpreting colour, we still have 2 eyes to see the world, but our camera has 1 eye and records in 2 dimensions only. So how do we work out how to represent a 3-dimensional world in a 2-dimensional image? How do we make sense out of all of these problems with colour? Well, we know, for instance, objects closer to the viewer seem to be sharper, more vibrant, more saturated, whereas objects in the distance tend to be softer, less saturated, less distinct. And we can use these ideas and techniques in our image making. And in future videos we're going to look at this and how we can use these fallacies with human vision and colour interpretation to great effect. So let's just review those 7 problems one more time. We know that colour doesn't exist outside our brains and that everybody sees colours differently. And we often see what we expect to see. And because the human eye is a very poor instrument, our perception can be easily fooled, and we can even be fooled into seeing things that aren't there. And how do we make our photographs believable with all those problems? In the next video, we'll find out how.